All right, let's jump right into this. We've got a fascinating story for you today, one that's all about how modern tech can breathe new life into these brilliant old ideas. We're talking robots, human collaboration, and the incredible power of simulation. Yeah, this quote from the original researcher, Dr. Yuri Kartan, just nails it, right? The idea does not change, but its reach does. The core concept we're about to dig into, it's literally 20 years old, but its real potential, well, that's only just now being unlocked.
I mean, just think about it for a second. What if all those amazing, groundbreaking ideas from back in the day weren't trapped by the technology of their time? Stuck in physical labs with clunky old computers. What could we learn if we could just set them free in today's digital world? Well, guess what? That's exactly what we're going to find out.
All right, let's get into the nitty-gritty. This whole story is about taking a concept that was originally tested on just one single physical robot and blowing it up, scaling it in a massive virtual world.
So, check out this timeline. We start way back in 2006. A really unique human-robot learning system gets tested on an actual industrial robot, and it even nabs a Best Student Paper Finalist award. Pretty cool. But of course, the experiments were super limited by the hardware. Now, let's fast forward 20 years to today. That exact same idea is being resurrected using modern simulation and synthetic data. And here's the kicker. It's all public now. The research is open source, so anyone, you, me, anybody, can run it, tweak it, and build on it.
Okay, so what was this big idea they were testing? Well, they put it to the test with a challenge that was surprisingly tricky and, a little bit weird, to be honest.
The mission, should the robot choose to accept it, was to strategically shape knotted objects out of a bag. Now, that might sound kind of simple, right? But for an AI, oh man, it's incredibly complex. It's dealing with all these hidden variables it can't even see, like how tight is the knot, how tangled are things in there. It's actually the perfect puzzle for a learning algorithm.
And the AI figures this all out using something called reinforcement learning. The easiest way to think about it is like training a dog. When the robot does something good, like shaking the bag just right to loosen an object, it gets a reward, a little digital treat. If it makes a bad move, it gets nothing. And over again, it learns to chase those rewards.
So it's just this constant loop, you see? Attempt the task, get a reward, tweak the strategy, and then do it all over again, and again, and again. For this experiment, the robot went through this learning loop 500 times to really get the hang of it.
Okay, now we get to the main event. Because this experiment wasn't just about watching one robot learn. No, it was a showdown. A head-to-head comparison between two different learning styles, all to answer one simple question. Can a little bit of human help actually boost an AI's learning?
So, in one corner, you've got the lone wolf. This AI is learning entirely on its own, just pure trial and error. And in the other corner, you have the coached player. It's also learning through trial and error. But, and this is key, if it starts to struggle, a human coach can jump in with a few helpful tips.
This whole method is called cooperative Q learning, or CQ lambda. Now, the important thing to get here is that the human doesn't take over the robot. Not at all. They just offer these simple linguistic bits of advice to kind of nudge the AI's strategy in the right direction when it gets stuck.
And the advice itself, it's so simple, it's almost funny. The human coach is just using these basic commands. Things like significantly increase this action or slightly decrease that one. They're telling the robot which kinds of shakes seem promising. And that simple feedback directly shapes the robot's strategy. No complex reprogramming needed.
So there you have it, the lone wolf versus the coach player. After 500 learning episodes, who do you think won? Let's look at the data.
And this is really the whole point, isn't it? Does that super simple human coaching actually make a difference? Does it lead to better performance?
Oh yeah, it absolutely does. It's not even close. If we look at the final accumulated reward, which is basically the final score, the coached player racked up 9,200 points. The lone wolf, it was way back at 7,100. That's a huge, clear-cut win.
Let's put a number on that. That's a 30% higher final reward, all for a robot that just got a few simple tips from a person. It didn't just learn, it learned smarter.
And we're not just talking about abstract points here. This translated to real results. The coached robot had a 21% higher success rate. That means it was just plain better at actually getting the job done, getting those knots out of the bag. And get this, it was faster too. That human guidance helped it figure out a more efficient strategy, so it completed the task 14% quicker on average. So let's add it all up.
The coached robot was more successful, more reliable, and more efficient. A total sweep.
Okay, so a robot that's really good at shaking bags? That's cool and all, but why should we care about this 20-year-old experiment today? What's the bigger picture here?
Because it's not really about the bag shaking. This is a massive proof of concept. It proves that we can go back into the scientific archives, this huge treasure chest of old research, pull out these brilliant ideas that were held back by old tech, and give them a whole new life with today's simulation tools.
And think about what that unlocks. It opens up so many doors. We can finally benchmark new ways for humans and AI to work together. We can study the absolute best ways to give an AI guidance. We can train robots safely in a simulation for thousands of hours before they ever touch anything in the real world. We can even make AI more explainable because we're using human language to teach it. And best of all, since it's open source, it democratizes the whole field. Anyone can grab this and start building the next cool thing.
So yeah, this whole thing started with just one idea from 2006 being brought back to life. It really makes you think, doesn't it? With this incredible new toolkit we have, with simulation and synthetic data, what other classic ideas, what other forgotten breakthroughs are just sitting out there, waiting for us to resurrect them?